If you ever wanted to test your own radios, then it is actually a lot easier than you think. In this video, I'm going to show you how you use the TinySA here to measure things such as output power and also spurious emissions of your common radios. It can be your handheld radio, it could be your mobile radio, it could even be your HF radio. All of the stuff that's going to be used in this video, there'll be a link in the description below so that you can go off and grab some of these bits and pieces if you don't have them. For instance, I've got the TinySA Ultra. There's two main versions of TinySA. So this version goes from 100 kilohertz to 800 megahertz, and then there's also an extended version which will go from extended mode, I should say, that goes from 800 megahertz right up to 5.3 gigs. There's another one that does, I think it's up to about 960 megahertz, so you'll only be able to measure up to those frequencies. So this one is a little bit more expensive. I'd recommend this one over the other TinySA. But if you want to just do basic measurements on the common ham bands or in up to a certain frequency, then certainly get the cheaper version. So what I'm going to do is I'm going to test and demonstrate here my Yaesu VX8. As you can see, there's a very important measurement here that's written on the side of the TinySA, and that's plus 6 dBm RF. That's the maximum amount of RF input that this will accept. So we need to make sure that we don't exceed that. So we're going to look at a little bit of maths here for a moment. So what we've got is we've got a maximum input of plus 6 dBm. We can't exceed this, and ideally we want to be less than this. So for our normal handheld radio here, that's a 5-watt transmitter, that is an output power of 37 dBm. So what we want to do is we want to reduce this to below plus 6 dBm. What I have here is I have two attenuators. So I've got this first attenuator with a large heatsink. This can handle up to 50 watts for a short period of time. It gets rather hot, but it is a 20 dB 50 watt attenuator. So basically I can pass a signal in on one side and it's going to be 20 dB down on the other side. So if we take away 20 dB from this measurement here, that's going to leave us with 17 dBm, which is still too high, plus 17 dBm I should say. It's going to be too high above our plus 6, so we're going to damage the front of the front end of the TinySA. So what I've got is I've got another 2-watt attenuator, 20 dB attenuator. So what I can do is I can pop that on the front of this existing attenuator, and now we've got 40 dB in total. Now this is just what I've got offhand. There is a link in the description below to a proper 40 dB attenuator which will handle the power of a normal small little handheld quite easily. So if we take another 20 dB off here, if we have a look at what our measurements are, if my maths is correct, we've now got minus 3 dBm. So we're at least 9 dBm off of the maximum. So we're going to be good to go there. Now obviously if you want to do higher RF output powers, you're going to have to increase the amount of attenuation that you actually put into the front end of this because you don't want to destroy it. And bearing in mind too is that whilst this can handle 50 watts for a very short period of time, that it won't do it for forever. It will heat up quite a lot. The other thing that we also want to consider is that if we do stack attenuators, that we do just check the power ratings. This other attenuator here is a 2-watt attenuator, so it will handle 2 watts going through here, so I couldn't plug it in the other way around. I can't have my radio directly into this attenuator because I'm going to blow that up. So that's why I'm sort of cascading it into this attenuator, and then it's going to go in at a lower power level into this one, and then it's going to be even lower into the TinySA. Hook up the Yaesu directly here to the larger attenuator through the SMA connection here to N, through this attenuator, through the smaller one, and then I've got another lot of connections here, and I'm going to go now into the RF port of the TinySA. Now I was using this the other day, so I'm going to reset this up. We're going to do a test on, let's just power on my radio, and if I slide this along, let's go to 146.5 00, which is our call channel here in Australia. I'm on high power, and I'm going to change my TinySA. I'm going to adjust a couple of settings here. I'm going to go in and let's go to frequency, and I'm going to have a start frequency of 146.5, and I'm going to go megahertz, M for megahertz, and you can see there that there is quite a very fast span happening there. I'm going to adjust the span. That's my center frequency, but I do want to see a little bit of a span to see how the signal actually looks. So I'm just going to adjust this span out. Let's just go 500 kilohertz, and it's just going to reset there. So the middle of this span here should be on 146.5, and we're plus and minus 250 kilohertz or 500 kilohertz total span here. So if I just key up now and transmit, and you can see there is our signal, our peak signal, and you can see that I've got a signal level of minus 1.8 dBm. Now, this hasn't accounted in for the external attenuation that I've actually got plugged in. So what we need to do is I need to go back into the menus, and I need to go to level, and you'll see here there's an EXT gain button there. So if I just tap on that, and we want to type in minus 40 because we're taking out 40 dB. We've got 40 dB of attenuation, that's why we're in the minus. So we just type in minus 40, and then that's going to reset. If we now transmit again, we've got our center carrier again, but you'll notice that the number has changed, and this time we've got a truer measurement there. We've got 38.3 dBm, which is pretty close to our 5 watts. And in actual fact, if we tap on the screen, we can go in the level, let me go back. We can go into the level adjustment, and we can change the unit from dBm into all of these different units, and let's go watt, and that's going to reset, and we can see there it's saying that we're roughly just over 5 watts, so between 6.7 and 7.6 it looks like there. So we can measure our wattage that way. Let's just go back to dBm. Now, a lot of people like to measure the harmonics of their radios. Basically, back into the menus, and we want to go to the measure menu first. So tick measure, and we want to go to harmonic. So we'll just tap on harmonic. So now it's going to ask us for the frequency of the fundamental. So we're going to stick on that same one of 146.5 and megahertz. So now we've got our span, and by default it's going to go all the way from 0 hertz, it looks like, up to 1.3 gigahertz. Now I don't want to quite go that sort of span. As you can see by this green line that's pulsing up and down, that's one sweep. It's going to take forever to do. Now we can do this, you can transmit and wait for the average to average itself out, but we're going to go in and let's go back to frequency. And we're going to click start, and let's just start at a frequency of, say, 100 megahertz. And let's stop at a frequency of, let's measure the first, second, and third harmonic. So that's going to be up to 70 centimeters. So let's stop at about 500 megahertz just for this test. So now that sees our sweep will be a lot quicker. Now we also want to put in a trace, so we can go into display and we can draw a line. So if we tap on draw a line, we can select the level. Now for the FCC rules, it is minus 16, I think it's 0.02 if you want to be pedantic, dBm. So that's going to draw a line here at minus 16 dBm. Now that we've gone and set that harmonic measurement, it's actually going to mess up our level that we've got. So what we need to do is we need to go back into level and reset our external gain back in here again. So we'll go negative 40. So now once we've done that, you'll see that everything has now shifted down. We've got our noise floor level down here, right down at the bottom. we've got our marker at -16. So what we ideally want is we want every harmonic, the fundamental is going to be higher than that, but we want every harmonic to be under that level there. And we've got the top end range of our meter here, so +40. So we're going to be measuring our measurements as far as our output power is concerned. Sorry, those two markers just threw me off there because I've got another transmitter here in the room that's transmitting, and you just saw that pop up for a second. So what we're going to do is let's hit transmit, and we'll see our markers are coming up. Now you do need to just hold down the transmit for a little while, because as you can see there is an average that is happening. It's going to take a little bit of time. The number 1 marker, which is our fundamental, has shifted up to almost to this 40 dB line. As you can see there, it's roughly what our measurement was that we measured with RF output power earlier. And you can see there that we've got no harmonics whatsoever. We've got our fundamental here, we've got no harmonics all the way up to 500 megahertz, which is very good. So here's an example of a dirty radio. I've got a Baofeng UV5R3 that is currently plugged in, and you can see here that as this averages out even more, our fundamental here on number 1, which is sitting at 32 dBm, we've now also got a second harmonic, and if I actually move the marker, you can see there the number 1 marker just by using the scroll button here on the top of the TinySA. I can move that there. Number 2 is about 294 megahertz or so. That's 26 dBm. So that's a fail. The third harmonic is sitting also above that line, and that is up at 438 or 439 or so in the 70 centimeter band. That's -14, so that's also a fail. And then there's also another little harmonic here, which is not that much of a worry, but the fourth harmonic there is sitting at -24 at 500 and something megahertz. So we get a cool overall viewpoint and look of what's going on with each transmitter that we test, which is really good and handy for testing your own radios out to make sure that they're compliant, that they're clean. So the other thing that you can do is you can connect an antenna, either the stock little whip here or any antenna really that you want, into the TinySA, and you can see all of the signals that are happening in your local area. So you can see I've got some signals here down the bottom end of the band at 100 megahertz, which is FM radio. If I keep scrolling up here, there's another frequency here, which is around about 160 megahertz there or so, another transmitter. And then also a little bit further up here at 170 megahertz, 180 megahertz, that's actually television broadcaster signals up that high in the band. I did some tests on a broadcast site at how bad this interference actually is when you're trying to operate on top of a mountaintop using your handheld radio. If you want to see what the results were and how bad it actually really is, then there's a video that will appear on the screen